Welcome to Statistics, everyone. Today is Sunday, March 29th, and we're going to continue our discussion of significance tests. The examples we talk about today will be helpful for your homework, which is due Monday night, homework 30, more on significance tests. And just as a quick reminder, in the announcement sections of WebAssign, you can find links to our previous videos and also download the slides that we used for those videos. So let's jump right into it. Um, Today, I would like to begin by looking at an example in the book, actually, an exercise in the book. We're in chapter 17, and this is exercise 17.15. Let's take a look. It begins by saying that people tend to be more generous after receiving good news. Are they less generous after receiving bad news? They investigated this by looking at the tip amounts left by patrons in a certain restaurant. The average tip left by adult Americans is about 20%. But for these particular 20 patrons, a message was left on their bill warning them that tomorrow's weather would be bad. And so this is sort of the bad news part of the experiment. Uh, then they recorded the percentage tip left by those patrons who received the sort of bad news about tomorrow's weather. And here's the data they give us. If you look at these are percentages: 18%, 19.1%, and so on. It indeed looks like the majority of these are indeed below 20. And so it looks like on the face of it that it may be true that the bad news about tomorrow's weather led to a reduction in the tip amount. Um, but of course, we want to subject that to a little more than just an eyeball analysis. After all, a skeptic could argue that, well, the average is 20% generally. And yeah, your data does look like it's a little bit low, but that could just be because you happen to get a bad sample. The 20 patrons that you recorded these tips from just might have been, by luck of the draw, poor tippers to begin with, and it had nothing to do with the actual message on the bill, but just the fact that you got this bad sample. And so we want to address that by performing a significance test. And so the problem gives us a little bit more information to go on. We're told to suppose that the tips are normally distributed with a standard deviation of 2. And then they ask, is there good evidence that the mean percentage tip will be less than 20%? Keep that question in mind. That's the alternative hypothesis, the statement we're looking for evidence for. And let's go ahead and take a look at how we work our way through this problem. So uh, here I've just sort of written the hypotheses using our statistical notation. The alternative hypothesis, the one we're looking for evidence for, is that the mean tip amount uh, is less than 20. And this would be the mean average tip among all patrons who received, a bad message about tomorrow's weather, not just the 20 in our sample. So that's our alternative hypothesis, that mean would go down because of the message about the bad weather. The null hypothesis is, of course, the skeptic's position, the devil's advocate position, I've called it, that no, the mean, the message about the weather will have no effect on the way people tip, and so the mean will remain to be 20. And it's important to know exactly what mean we're talking about here. And again, that's the true mean tip percentage among all patrons who would receive that bad weather message on their bill. Um, so let's just review our assumptions and our sample data going forward. We always will assume that our sample data come from an SRS, and the variable in this case, the tip percentage, we assume has a normal distribution with an unknown mean, but a standard deviation that is known. In this case, we were told that the standard deviation was 2 percentage points for the tip amount. And our sample data came from a sample of size n equal 20. And I went ahead and just averaged these 20 uh, tip amounts there, tip percentages, using my calculator. And that sample average, that X bar, was 18.19. So it's definitely true that the sample average tip was less than 20%. But keep in mind that the question we're asking in a significance test is not about a sample average, but it's about the true population average, right? Um, there's no disputing that the 20 patrons in this sample tipped less than 20% on average. But the question is, what would all patrons do? What would be the average among all patrons if they received a similar message on our bill? That's what we're investigating in the significance test. So our data do seem to support on the alternative hypothesis that the true mean is less than 20, but of course they're not. It's not definitive support. After all, the skeptic could argue that you haven't you haven't sampled all patrons. You've only sampled the 20 that were in the study, and so we need to see if we can what we can learn about the true mean mu from this sample mean of 18.19. The basic ideas to keep in mind going forward here, well, the central idea is the sampling distribution of X bar. That is going to enable us to relate X bar to the true mean mu. And so here, applying the central limit theorem, we know that X bar has a normal distribution with a mean that's unknown still, but whatever it is, it's the same as the true mean in the population, that true average tip amount. And the standard deviation of X bar is the population standard deviation, or sigma, divided by the square root of the sample size. From that, we get the test statistic for our significance test. The test statistic is just the z-score for X bar, assuming that the null hypothesis, that mu equals 20, is true. And so I've just computed that here. That's our X bar minus mu over the standard deviation of X bar. So that's our 20 over 2 over square root of 20. And so that turns out to be actually negative 4.0473. Let's pause for a minute to just remember what that means. What we're saying is that if the null hypothesis were true, then the data that we have would be more than 4 standard deviations below where we would expect it to be. This would seem to be pretty strong evidence in favor of the alternative hypothesis, because it would be really rare to see data 4 deviations below the mean if this null hypothesis were true. So, data that would be rare if the null hypothesis is true is actually data that's in favor of the alternative hypothesis. That's the idea here. Okay, but how strong is the evidence against H0 and in favor of the alternative hypothesis HA? Well, there is where we want to calculate a p-value. And I'm just reminding you here of what the p-value is. It's the probability, assuming the null hypothesis is true, of all test statistics that are at least as extreme as the observed test statistic against the null hypothesis and in favor of the alternative. Now, what is the alternative hypothesis here? Let me just remind you. It's that the true mean is less than 20. So what would a test statistic that's at least as strong as ours in favor of HA be? Well, our test statistic was in favor of HA because it was less than the hypothesized mean from the null hypothesis. Data that would be even more strongly in favor of HA than ours would be z-scores that were smaller than ours, right? Because the alternative hypothesis is that the uh, true mean is smaller than 20. So data that would be at least as favorable as ours in favor of HA would be these z-values that are less than minus 4.0473, our observed z-value. And those are the z-values we need the probability of. And so once you know that, you can calculate that probability easily using normal CDF. Remember, this is a standard normal curve here because we're talking about z-scores. And so it would just be the probability under a standard normal distribution that z is less than negative 4.0473. So here we do that calculation, and you find a very small value, 2.5921 times 10 to the minus fifth. If you write that out, that's 0.1234 zeros and then 25921. Remember, 1% would be 0.01. So this is a p-value that's far smaller than 1%. And also recall that small p-values count as evidence in favor of the alternative hypothesis, and the smaller the p-value, the more in favor. And so this guy here is very strong evidence against the null hypothesis and in favor of the alternative that mu is less than 20. So I've simply recorded that observation here. And then to bring in the idea of the significance level, remember we reject the null hypothesis if our p-value is less than the significance level. So at a standard kind of significance level of, say, 1% here, we do indeed have p less than alpha. And so we reject H0, the null hypothesis, in favor of the alternative. So to sum things up, our sample data gave us statistically significant evidence, p much smaller than 1%, that the mean tip percentage is indeed less than 20% when the message contains information about tomorrow's weather being bad. And remember, when we say this, we're making a prediction, really. We're saying that if you could go out and sample all restaurant patrons who received a negative message about tomorrow's weather on their bill, we're predicting that you would find that on average those patrons tipped less than 20%. So this thing is called a left tail test precisely because of the computation of the p-value here. It involved a left tail, and that's again because of the form of the alternative hypothesis. The book has a fairly nice summary of this. Let me see if I can pull that up real quick. I think if I go back a page or two here, we can find it. Yes, here it is. We just did a left tail test, which is this second type here in their little summary box. And this is on page 401 of the text. You may recall that our first video about weights of young men in Farmville was a right tail test. That's this first line here. There's one remaining test, and it's called a two-sided test. And we'll have a video addressing that very shortly. But in the meantime, that's it for right now. So go ahead and take a look at the homework, and if you have questions, let me know by email. And stay tuned, stay in touch, and stay well. Best wishes to everyone, and we'll see you again soon.